with number 3, have you done FOIL in your class? Have you done a binomial times a binomial?
Yeah.
Did you call it FOIL in your class too? No, what did you call it?
I'm not sure.
Not sure. Maybe you guys multiplied vertically or something. We did a little bit of that too. Cool. Okay, so let's see how this goes. I'm just kind of curious to see if you've done this yet. So Danny, when you did your firsts, what did you get?
I got 9x squared.
All right, so 9x squared for your firsts. I agree. Avery, how about your outers? When you multiplied the...
Oh.
So here was your first. 15x.
Yeah.
Agreed. Hey ladies, you with me?
Sorry.
Ellie, how about your inners? What'd you get?
I messed it up.
Oh man, Christiana, did you mess it up too?
No.
Okay, what'd you get for your inners?
My inners, I got negative 15x and negative 25.
And for your last, you got negative 25. Okay, so it's a really important pattern. When you add up your middles, what happens? Zero. They add out. That's right. And so, typically if this had been earlier in this, I guess this would have been last chapter, right? Yeah, last chapter, we would have written 9x squared minus 25. We call it good. Full credit. Yay, right? So what we're going to do now is we're going to talk about how we could factor something like this. Like, in other words, what if we wanted to start with 9x squared minus 25 and go backwards and find the factors that multiply to be that? There's a lot of different ways that you could think about this. You could think about your b being 0. You could also have some recognition. So I think this is the easiest way to go. I want you guys to recognize something. Please notice that the first term is what we call a perfect square. So 9 is a perfect square. In fact, it's what squared?
3 squared.
3 squared, right? And x squared is a perfect squared. 25 is really what? 5 squared. So if we wanted to, we could think of this, we could think of this as 3x in parentheses squared minus 5 in parentheses squared. The important thing I want you guys to recognize is that we could give this a name, the name that you'll see in your book, that you'll hear a lot of math people use here, is they'll call this the difference of squares. Why do you think they would call it that? Difference of squares. Yeah, one's negative, one's positive. And what does the word difference mean? It means subtraction. It means subtraction, that's right. And of course, you've got perfect squares. So what we would do here, once we recognize that we have the difference of squares, we can factor it directly. And we can factor it, as we know, 3x minus 5, 3x plus 5. Of course, that's what we started with, so we basically have foiled and then just undone the foil. So I want to do one or two of these examples with you, and then we will do some practicing. I used a word just a second ago that I think is important for us to understand. I used the word recognize. That's a pretty loaded word, right? Like, wouldn't it be weird if today you went home from school, you opened your front door, maybe your mom, dad, sister, brother, somebody is there, somebody that you know very well, and they looked at you and they're just kind of like, who are you and what are you doing in my house? Would that be a little bit weird?
A little bit.
Wouldn't you look at them and say, don't you recognize me? I'm Ellie, your daughter, your sister, whoever, right?
Right.
You would expect that. Why would you expect your parents or your sister, your brother, whoever, to recognize you? Because they've seen you many, many, many times. They've known you perhaps since even, like the day you were born, they've known you a lot, right? So they've seen you repeatedly. So the implication here is this. If we're going to recognize the difference of squares, we're going to have to see it a lot, right? So we're going to practice at the board here. But let's start off by kind of introducing ourselves to it. So I look at number 4. It says factor completely. And I look at what I've got. It's a little bit different. It's a binomial instead of a trinomial. Here's what I would want you guys to do. I would want you to look carefully and recognize a couple of characteristics. Number 1, it's a difference, right? It's not a plus or a times or a divided by. It's specifically a minus. And you look a little bit deeper and you look at the first term. The first term is a perfect square, isn't it? 16. And you look at the second term, 100. Those are both perfect squares. So maybe you could think this, or you could write this out. You could think of 16 as really 4 squared, x squared is really x squared, and then 100 could be rewritten as what?
10x squared.
Not 10x squared.
Minus 10x squared.
Not 10x squared, just 10 squared. There's no x with the 100. Okay, so once you recognize that this is the difference of squares, you can then immediately go to the factoring, and it would be 4x minus 10, 4x plus 10. What if you had your doubts? Like Rocky looks like he kind of has his doubts right now. If you were a little confused, if you had your doubts, maybe you tried something like that, how could you confirm that that is the right answer, or maybe say it's the wrong answer? What could you do? You could just FOIL it back out. And if you end up with 16x squared minus 100, in other words, if the middle terms add out, then you can be confident you got it right. Does that make sense, Rocky? Maybe we need to do some more so you'll recognize it. Yeah, Jake, go ahead.
So how did you get the 4x plus 10?
So what I am wanting you guys to recognize, it's a good question. We started with this for a reason, up here in number 3. I want you guys to recognize that when you have 3x minus 5 times 3x plus 5, notice that all of those terms are exactly the same, right? Except for the minus and the plus. When you have that pattern, the two middle terms, in this case it was negative 15x and positive 15x, those always add out to be 0, leaving us with this pattern right here, a perfect square minus a perfect square. So Jake, one way we could kind of check this a little bit for you, if you're like, hey, where'd you get the 4x plus 10, where'd you get the 4x minus 10? I think I would do what I suggested to Rocky, and that's FOIL it back out. Check out what happens when I FOIL it back out. 4x times 4x is what?
16x squared.
Yep, bless you. What about your outers? What do you get there?
40x.
And what about your inners?
Negative 40x.
Look at that. Yeah, that's the pattern we were hoping to get.
100.
Minus 100, of course, these add out, and so it checks. So oftentimes when you ask yourself, hey, where did this go? Where did this come from? Let's like check it. Let's go backwards to see really where did it come from or where did it go. We should be able to see it. All right. Let's go ahead and try our other one, and then we'll get to the board. Give it a try, and if we need to fix stuff, we'll fix stuff. Hunter, did you already do it? Rocky, did you already do it? So you're not as confuzzled as you thought. Cool.
Will it ever be like a perfect square plus another perfect square? Or would always
It has to be difference. If it's plus, it doesn't work.
Okay.
Yeah, it's got to be minus. Good question. Alec, you already got it? Evan, you got it? You guys are seeing the pattern pretty quick? Awesome. That's good, that's good, that's good. Okay, Sam, did you get it?
I did.
Would you mind sharing your answer with us?
9x minus 7 and 9x plus 7.
You guys all chit-chatting because you are so confident? Did you guys agree with Sam? Yeah? 9x minus 7, 9x plus 7. Sam, good job. You're right. What do you have?
We got 9x parentheses squared minus 7x.
So this? Did I write it correctly?
Yeah.
So that's a good start. Hey, you know what? I'm glad you brought that up. So that's a really good start. I want to remind you, though, what factoring is. Factoring is taking something that is not a multiplication problem and turning it into a multiplication problem. So if you look at what you guys have right here, that's still a subtraction problem, right? And so that means you're not done yet. So what you did was not wrong. You're just not finished. Does that make sense?
What do you do after that?
So you recognize that this is the difference of squares. And here's another way to, if you want to do it this way, here's another way to think about it. Once you recognize that the difference of squares, it's going to be something plus something, something minus something.
Okay.
And then the something would be this and this.
Okay.
So it'd be 9x and 7, 9x and 7.
Okay, I got it.
Yeah, okay. You guys good? Can we do the partner thing at the board?
Wait, what?
So remember,